Hello, my name is Manasi Kale, and for my STEAM project and senior project, I did a construction for database to aid in year-end report generation. So why did I choose this project? I chose this project because it would allow me to gain some real-life experience working in an IT field, and I really love computer science. So for me, this was an opportunity to not only further my knowledge in databases and general computing principles, but also a chance to really put this on my resume and kind of work with it and learn more. Who's my client? So my client is the nonprofit organization and a volunteer organization, the Bay State Trail Riders Association, or the BSTRA. They're stationed in Douglas, Massachusetts. Their goals are to preserve and maintain multi-purpose trails that are equestrian-friendly, creating new and connecting old trails for outdoor recreation and fitness, and promoting responsible use of trails. So what is my project? My project is to create a database for them. Currently, their record keeping for all of their volunteer hours is done through emails, paper forms, and through an app called the Point app that a few of their volunteers use. My goal is to create a database so that all of this data can be stored together in one location, make it easier for report generation, and to automatically create the reports to cut down on their time and make it more efficient. So my mentors, my past uncle, Abe Warimbe, my father, Amod Kale, Vinod K, who's a bachelor's in engineering, Soloni Walimbe, who's a master's in data science, and my client, Ms. Gallagher, who's the president of the Bay State Trail Riders Association. Timeline. I started this project in early June by trying to first scrape the Point app, which a few of the volunteers used. Sadly, this failed because the data was coming out in an unusable format, and I couldn't manipulate it so I could scrape the data that would come out in a usable format. From there, I decided to change my idea and focus on the paper forms that they were using and see if I could change them into an electronic format as PDFs. To do this, my client, Ms. Gallagher, did this for me and sent them over. But because all of the paper forms were handwritten, I had to use optical character recognition, or OCR, which is a process that converts an image of text into machine-readable text format. I first tried this through PyTesseract, which is a library in Python. Sadly, this didn't work out because the library didn't support the syntax and it didn't have what I needed to be able to convert all of the PDFs into legible text formats. From there, I tried convolutional neural networks. This took a lot of time, but it also didn't work out because I couldn't really figure out how to apply that new knowledge that I'd acquired onto this project, and I couldn't find a mentor who would be able to help me. So from there, I decided to change my idea again and thought, since the old forms that they have and all of the old hours that they have from previous years, the organization doesn't really need, they need the new hours. If I could have the volunteers submit their data into a new form, I'd be able to compile all the records a little bit faster and not deal with all of the prior information that they have compiled currently. So I built a form and had it uploaded to the BSTRA website. There's a picture in the later slide. From there, my goal was to figure out how to store all the data. For this, I acquired Microsoft Access and spent some time learning it. After I got a bit of a know-how of Microsoft Access, I started setting up the database outline. So all of my tables, my columns, headers, rows, all of that information. After that, I was creating ID keys as primary keys. ID keys are a unique number that's assigned to each data record and set. This is done to reduce redundancy and to prevent duplicate data. From there, I made my macros and queries to further format the data so that when it was all being sorted into the various tables, it would all come out very cleanly. The queries sadly didn't work out. After that, I was creating user interfaces to make sure that my client, Ms. Gallagher, could use the database smoothly, efficiently, and with little confusion. And after that, I was doing my pure programming with Visual Basic Application, or VBA code. So this is the form on the BSTRA website. That is how the volunteers are currently submitting their volunteer hours. Some challenges that I faced. I was unable to scrape the data from the Point app since it was coming out in an unusable format. The optical character recognition failed both through PyTesseract because the library didn't support the necessary syntax and because I couldn't find a mentor for the convolutional neural networks to apply it to this project. From there, the queries were also not working out when I got to building them because they weren't able to select the correct primary key or ID key for when I was trying to call up the data records, so they weren't able to format the data as I needed them to. Then the VBA code, I made a loop so that all of the records would be sorted and opened, and that didn't work. It failed 3 times. The first was due to a syntax error, which was an easy fix but took time to find the error. The second one was a logic error. It was the same situation with the primary keys as with the queries in that it was pulling out the correct primary key, but it wasn't being associated with the correct record set, so it wasn't finding the right record set because of that. The last one was error handling. To make sure that there was no blank values, the error handling was put in, but that code at some points was failing, so it also didn't work out all that well. And then my biggest challenge in all of this was Microsoft Access itself. This is a tool that is rather old, and it wasn't able to handle the amount of code and data that was stored in that database, so it was glitching, buffering, and it just generally kept crashing on me. So what my product looked like. This is the join relationship between the volunteers' hours rates table, the volunteer info table, the venue table, the categories table, and the activity hours table. This is made so the data can flow smoothly between all of the tables. This is the volunteer table. It's made to house the basic contact information of each volunteer. This is the categories table in the spreadsheet view and the design view. When the database is first opened and the tables are displayed, they're always done in the categories view or the spreadsheet view. This table was made to simplify the report generation. Each of the reports was supposed to be broken down per category with listings for things such as how many hours each volunteer was putting into what categories, what volunteers were participating in what events, and what venues did the events take place at, etc. This was made to make it easier to break all that down when the report generation occurred. This is the venue table, the volunteer rates table, and the form to upload the file for the volunteer hours. The venue table is meant to hold locations for each event. The volunteer rates table was created in case the rates at which each volunteer works and is rewarded for changes. And the form to upload the file for the volunteer hours, it goes together with some VBA code shown later. It's made so that the data downloaded from the form on the BSTRA website, that comes in the .xlsx format or the .xlx format, which is similar to a comma-separated values format or CSV. This is just a place to upload the form to the database to make it easier to get the data imported. This is the raw volunteer hours table and the volunteer hourly rate information form. The raw volunteer hours table, it's what the data looks like when it's first imported into MS Access, straight from that file when it's downloaded from the form on the BSTRA website. This is just where it's raw imported straight into and set so that all the data is there before it disappears or is lost in translation. The volunteer hourly rate information form, this is just to make the changes to the rates and automatically update all the corresponding data. Then the volunteer information form. It was my hope that I could use this and replace it instead of that form on the BSTRA website, so that there's the quicker data flow because it's already inbuilt into the database and it has less chances of errors in case data corruption or data is lost in the transformation process. Then the volunteer info form code. This makes sure that only .xlsx or .xlx files can be uploaded to the database. These two pieces of code are furthering the prior piece of code. They're just add-ons to that one. And they're also meant for error handling. They're to make sure that if a form that isn't the .xlsx or .xlx form is uploaded, the error is caught and reported back to the user who's trying to upload the form, and then it's also done to make sure that when the file is uploaded, the user knows that it's been completed and saved to the database. This is code for the function that will go inside of the loop. Its job is to open the record set and initialize the database. This is further following the previous piece of code. It looks up each data record and matches it to a volunteer using their first and last name. This is another piece of code inside the same loop. Its job is to initialize a bunch of variables for each cell per column and row, and later make sorting data easier by using a massive array. This is code to make sure MS Access knows that the data that has been uploaded is to the correct database and to the correct record set. This is code for error handling. Its purpose is to make sure each value is in the correct format and that the values being passed don't contain any blank, void, or null cells, or basically no missing data. If there is a case of missing data, it's also made such that the error is caught and then changed to a different value that's set already. And this last piece of code is just a continuation of the prior and shows the counter at the bottom with the rst.moveNext, which is the increment counter, and the very end of the loop. It's really just more error handling. So what I've learned from this project. Projects fail, and sometimes there's nothing you can realistically do to prevent that. This project has fought me every step of the way as I've done it. Programming is a lot of theory-based work, and it's all technical, so it's going to take a lot of time. It definitely took me a lot of time to do the programming. And in real life, projects like this are done in groups, and everyone has a very specific part they play. You can't really finish a project like this efficiently as a one-person team, as I tried to do. And thank you to all of my mentors.